Now, let's go for the last method that we're going to do in the areas, which is the using the coordinates. If we have a certain traverse, and at the end of the traverse, we will find and that's why we call it traverse area, because this is a very good application, but you can apply it to any area with the coordinates. So we have the coordinates E1, E2, N1, E1, N1, E2, N2, E3, N3, and then we reach E5, N5. How do we calculate the area of the shape based on the coordinates of the corners? Straightforward. You take the points, as you can see here. We are going counterclockwise. We started with 1 and 2, and we were going in a counterclockwise direction. So we will list the points. Point 1, E1. And then next to it, we'll put E2, and then E3, and E4. We continue to the last point. Now, if you want to calculate the area, it should be closed. You cannot, like, what is the area of this shape? No area. But if you want to close, you have to close it. Then you have an area here. So the same thing. When you list to the last point, which is E5, you have to go to the first point. So here we are listing E1 again. Start from E1, you end up at E1 again. If you want to start from point 2, you have to go all the way and come back to point 2. From point 3, go ahead to point 3, and you can go in sequence until you come back to point 3. No problem. The numbers at the beginning would be different, but the final result of the area would be the same. Now, what is next? We listed the E's. We now list the N's. So E1, we put N1, and then N2, then N3, then N4, until the last N, and we return back to the first point we started from. Now, the rest of the calculation, this is the principle. The rest of the calculation is straightforward. What are we going to do? Look at this. We will calculate two values. One is called K1, and the other is called K2. K1, all right, it is coming from E1 multiplied by N2, E2 multiplied by N3, and so on and so forth, until you go to the end point multiplied by the first point. And this is what is K1. And then we'll go for K2. And K2, it is E2 multiplied by N1, E3 by N2, E4 by N3. And we continue to the end, the ending point with N minus 1, and then the first point by the last point. And this is what? This is K2. What is the area? The area is K1 minus K2. K1 minus K2, it will give you double the area. So we take the difference and we divide it by 2. And this is the area. Now, somebody is asking, I can hear Saeed Shamsi asking, what about if K1, is it always greater than K2? So always the result will be positive? The answer is this. K1 will always be bigger, okay, if you go counterclockwise with the points. K1 will always be bigger and K2 is smaller, so the area, when you divide it by 2, the area will be positive. If by any chance you went clockwise, so from point 1 to point 5 to point 4, where is the, from point 1 you went to point 5, then to point 4, then to point 3, to the point 2, and then back to point 1, this will give you negative value. If you see that this is a negative value, look back, how did you proceed? You will see that you proceeded in a clockwise sequence, and that's it. All what you have to do is take the absolute value of the area and just flip the sign. Instead of negative, just make it positive. We know why it is negative, because we are going in a clockwise rotation. So try to go counterclockwise. It doesn't matter if you want to go clockwise, but expect that when you are doing it clockwise, that your area will be negative, so you will take the absolute value there. Now, we have numbers. As I said, here we are starting from E1 and N1. E1, which was 0, which is started from point F. And then we went to 77 and 0, which is point, we are going counterclockwise, and this is F, and this is D, and this is C, etc. What is this? This is point F again, which is 0 and 38.89, 39.89. Oh, this is that's okay. This is this should be 38.89. The calculations, they are done using Excel, so the result is correct. But we have to double check. I've been years using this example. This is the first time I see this blunder. All right, I will double check and fix this slide. So this will be, should be 38.89, or this one should be 39.89. No, it should be 38. Yeah, this is what is given here is 38.89. All right, so this is the point F. We started with point F, and this return to the starting point is the major reason why students make mistakes in the solution, because they forget to return to the point again. They forget to list the point here. They will stop at the last point. They do not continue to the point after that. So make sure that always you come back to the same point. As I said, here we started from point F. If you want to start from point C, go to these points and return to point C, no problem. These numbers, the multiplications K1 and K2 will be different, but the difference divided by 2 will be the same. Counterclockwise will give you a positive area. Clockwise will give you numerically the same, but the difference is in the sign. So you have to take the absolute value. Now, we have example to strengthen your understanding. What is the understanding? Is that this is I have no solution here. You have to do it at home. This is always in the exam, okay? This is always in the exam. That's why you have to know this. You have to practice this. It is straightforward, but you have to know it. What is it? Now, this is 0, 0. And this is 10, 0, which means this is 10. And this is 10, 10, which means this is 10. So this is a square. So what is the area of the square? 10 by 10, this is 100. So the area here, it should be 100. Now, we're going to do it using the coordinates. So K1, now, where are you going to start from? I put as a starting point here. Why? Because when I want to see the solution in the exam, I want to mark the exam, I need all the students to start and finish the same way, so I will not be calculating for everyone. But it is your choice. In the regular situation, you can start from any point and return to that same point. But starting from here, so K1, we said we want to see it is 0 and 0. And the second point, this is the arrow, going to 10 and 0. And then go to 10 and 10. And we go to 0 and 10. So we finished here, but we have to go back to the same point, so it is 0 and 0. And now we want to start the E1, N1, N2, and this is 0 by 0 for the K1, and this is 10 by 10. So 0 and 0, this is 0, plus 10 by 10, this is 100, and 10 by 10, this is another 100. 0 by 0, this is a 0. So this is 200. All right. Let's go for the K2. K2 is 10 by 0. This is 0. Plus 10 by 0. This is a 0. then 0 by 10, this is a 0, plus 0 by 10, this is another 0. So this is a 0. So 200 and a 0. So 200 here minus 0 over 2, and this equals 100 over 200 over 2, and this equals 100. See how nice it is. Now, if you do not connect the corner ones, I want to go from the middle to the middle to the middle to the middle. And now we need to know that if you go from the middle point to the middle point, we are calculating the area of the shape. From the starting point, straight line to the second point, straight line to the point after, straight line to the point after, and straight line to the point that we started from. So here you have to know that the sequence of the points is very important, because the shape that you will calculate its area using this method, it is the shape that connects the points in sequence. Now, so the sequence of the points is very important. Now, the same thing, you put the points and you will find this is an area of certain amount. What is the should be the area here? As you can see, this is 5 over 5. The area here, 1 over 5 multiplied by 5. So this is 25 over 2. This is 12 and a half. And this one is 12 and a half, 25 and 2 and a half. This is 25. 12. So this is 50 and this is 50. So this inside will be 50, the outside will be 50. So this is half of the shape, which is right. If you do it using the trapezoid, the coordinate method, you will get the same thing. And if you take the corner points and the middle points in sequence, you start, for example, from 10, 10, go to this point, go to this point, and to this point, and to this point, and to this point, and to this point, you will see that the area is 100 again. What is the difference between this, when we have also the middle points, and the original method here, is that we have more points. We have more points, K1 and K2. Now they are calculated from more points, but the result is the same. So what does it tell you here? It tells you that if you have extra points on the same line, okay, all what they are going to do is that they increase the calculations, and the difference in the is nothing, zero. So if you have points in the middle of a straight line between 2 points, that this point here and this point here, they are on a straight line, and this point, this extra point, is on the same straight line, do not include it in the solution, because it will not affect the solution. And this is what we will be benefiting from this. So you have to do this to convince yourself that the area will be the same. Now, what are we going to do here is that start from here, which is 1 meter, 9, 10, and this is 1 meter, and this is 1 meter. I'm trying to start from here, go to this point, and then go back to this. Do not go to the corner point, to the other point, 0, 9, 1, 10, and go to this point. Like this is the shape that we are calculating its area. What is the shape? It is the whole area, which is supposedly 100, minus the 4 small triangles. The triangle here, it is 1 by 1. So the area of this, it is 1 by 1 divided by 2. This is 0.5, and this is 0.5. All of these, they are subtracted because they are not included in the figure. So 100 minus 2, so should be, if you use the coordinates method here, it should give you 98. Try to do it and see if it is 98 or not. Again, if you take in sequence the corner point, the quarter point, let me call it like this, and this point, and this point, and this point, and you continue with all of these points, the area will cover the same original shape, and the area should be 100. What is the effect here is that we are using 1, 2, 3, and 3, and 3, and 3. We are using 12 more points, intermediate points on a straight line between the corner points, and they will not affect the solution. So all what we have, we get is that we will have extra work, extra time, extra effort, extra errors. So make sure that if you have points on the same line, do not include them. Like in this example. In this example, we have eastern direction, northern direction, okay? And these points, I will give you distances. And I'll ask you, I want you to solve this question using the coordinates method. Coordinates method, okay. What do I need for coordinates method? I need coordinates. So where shall I put? I will not give you N, I will not give you E. Where are they, the eastern and northern coordinates? I will give you just this shape, and I will give you the distances. You suggest, because it doesn't matter if this is 0 and 0 or 10 and 10. Like if you want to say here, it is 10, 0, 0 and 10, 0. You can say this is 10 and 10, and this is 20 and 10. So the distances is the same. The coordinates, they are different, but no problem. The shape is still the same shape, the same size, the same area. So here, you say where is the coordinate system you wanted. So I would say I will put it here. So if I put it here, the E and N, that's okay. But here we have negative coordinates for B and A. I would not do that. So let's just keep it at this point. Choose it so as your calculations are fast. So here we have, if you take A 0 and 0, B will be 50 and 0. And C will be 50 plus 30, this is 80 and 0. And you continue. But do you need all of these points? I will not need these points. Why? Because A and G, all right, they are on a straight line. And these points, they are on a in between two points that are on a straight line. I do not need them. So I will put A, which is the 0 and 0, and I will jump to G, and G will be, I don't know, 50, 80, 120, 140, 170, and 200. Maybe this is 200, and the Y is 0. Then I will go to the 0.7, and then I will go, I don't know, 0.7 and 0.6 and 0.5. Are they on the same line? If yes, I will skip 0.6. I will go to, from 0.7, I will go to 0.5. And then I go to 0.4 and 0.3, because these are points which are not on a straight line. 3, and then back to 2, then back to 1, and then I have to return back to A. Don't forget to go back to the starting point. I will list the coordinates after I calculate them. Like here, this is 50 and this is 46. So 0.2, it is 50 in the E and 46 in the north. And the same thing for 3. It is 50 plus 30. This is 80 in the E and 38 in the north. So these are also what you should do with in this case. So now we'll calculate the area using the trapezoid, using the coordinates method. Look what happens if we rotate the shape. This is the same shape that we want to use to calculate its area. Now it is not coinciding with the E and N. The shape is the same area, the same shape. Either it is in the same original rotation or it is rotated. So in this case, if you want to calculate the coordinates of B with respect to the original E and N coordinates, this will be a pain. So look at the shape. Oops, I can calculate the coordinates with respect to a rotated coordinate system, which is E and N. I would say this is 0 and 0. And this will be the same. It is 50. With respect to what? With respect to the new coordinate system. I don't care what the coordinates will be numerically. I don't care about that. because they will give me, at the end, they will give me the same area. It is the same shape. So the same shape, it is here, let's say a square, which is 10 by 10. If it is in Al Ain, or if it is in Abu Dhabi, or in Sharjah, it has the same area. 10 by 10, it is 100. So here, if you rotate it, if you take it from one point to the other, it is still the same shape. So it will have the same area. So here, instead of finding the coordinates with the original coordinate system, which will be really a problem because of the rotation angle, do the coordinates with respect to the rotated coordinate system, and then you will do the same. And again, you do not want to consider these because these are on a straight line. At the end, these are the tricks that you have to consider when you are solving a question. When I give you in the exam, maybe you will look at a problem like that and say, wow, so complicated, so long. No, 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 no. Take out the points that are on a straight line, rotate the coordinate system and calculate the coordinates from the rotated coordinate system, and you will do that in a matter of minutes. So work smart.